Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X research and professional physicist. And today I'd like to bring to you another one of my articles. This one's entitled Planet X Trajectories, Why Are They Curved? Now, Planet X objects or Planet X system stellar cores, which come into the solar system as comets, and you may look at Article 367 entitled Planet X coming in as comets and affecting the Earth, follow curved trajectories. We know that because they come in as comets, and comets follow curved trajectories. The interaction bringing them to the Sun is the electrical interaction, which causes positively and negatively charged objects to be attracted to each other. The stellar cores are positively charged, and the Sun's outer layer is negatively charged. So they are attracted to the Sun's outer layer. Those objects that come toward Earth will also be attracted to the Earth's outer layer of electrons. Very large objects are, however, not attracted to the Earth due to an effect called gravitational tuning, which only allows objects of comparable electric potential or energy level to interact through the electrical interaction. And you may look at Article 569 entitled Effect of Planet X Objects as Large as the Sun on the Earth, Energy Levels. And here you see some of these objects, and this is one of them in the Sun's corona, one of the Planet X system stellar cores. And you can see that this one has stripes, which makes it look a lot like Jupiter. And you can see the stripes are curved because they follow the contours of a clearly spherical object in the Sun's corona. And here's another one. It's clearly a spherical object, and there's a CME coming from the Sun. It's obviously connecting with the object, and these objects induce CMEs, which are matter creation events in the Sun's core. And for more details on that, you may look at Article 522 entitled Stellar Cores are Sources of Matter or White Holes. And here you see Comet Neat, which would be either one of these stellar cores coming in towards the Sun or debris that belongs to the debris fields that we find around these objects. And we know these comets, of course, follow curved trajectories. Now, both the Sun and the Earth rotate, so an object making a connection with a region in the Sun's outer layer will automatically be pulled sideways by the rotational motion of that electron layer so that its trajectory is curved. And this is illustrated in this diagram. If a stellar core connected to the center of the Sun, we would expect it to come in a straight line towards the Sun. And if it connected to the outer layer of the Sun, but the Sun did not rotate, we'd also expect it to move in towards that point on the Sun. But it connects to the outer layer and the Sun rotates, which means that this point it connects with has rotational motion, which gives the object rotational motion as well. And that means that it will follow a curved path. Then once the object comes in and actually touches the Sun's atmosphere or comes into the Sun, we would expect it to rotate at the same rate as the Sun because now it's directly connected. It's like being an object inside the Sun's atmosphere. So they will still not connect with the Sun's center at this point. They will at the stage rotate with the Sun, as I said. In other words, they will tend to remain stationary with respect to the Sun until they are ejected once the concentration of electrons in the Sun's corona at the correct energy level drops. So they are connecting to electrons at this point on the Sun. And once that concentration of electrons drops, then the force which causes them to be attracted towards that point disappears. And this is illustrated here. So we have a stellar core which is arriving at the Sun severely depleted in gravitational energy. So its gravitational potential is VG100. It's the gravitational potential for an orbit that's way out there, very far from the Sun. But its electrical potential is VE3. So that's an electric potential for matter here inside the Sun itself. And that means that there are two forces. There is the electrostatic force, which is attractive, which causes the object to be attracted to this layer of electrons. So this will be the outer electron layer at energy level 3. So this object is attracted to electrons in this layer. And then there's the gravitational force, which is the interaction that the object has with the sun's inner proton layer, which will be inside the body of the sun, and is represented by this red circle here. And that force is, as I said before, repulsive, because the gravitational potential is so low that according to the gravitational potential, the object should be way out there, but it came in because of its high electric potential. So once the number of electrons are at this energy level drop in this region, this force disappears, so the object is ejected due to this repulsive force. Thus, the curved trajectory followed by Planet X system stellar cores going toward the sun is a consequence of them interacting with the sun's outer layer rather than with the center of the sun. Newly created planets would also follow curved paths because they are ejected from a parent object, which is rotating and will thus be rotating at the same rate as the parent as they move through its outer layers. Once a new planet leaves its parent's body, though, it will start orbiting the parent at the speed which is associated to its core's electric potential or energy level, as it settles in the correct orbit for its core's energy level or proton density. The position of these energy levels is set by the parent celestial object, core's electrical potential, and proton density. And you may look at Article 571 entitled Planet X in Our Skies, Water, and Vortices. And this illustrates how larger stars will have a larger electric potential, and its energy levels will be much larger and further apart than those of a small star. So here we have a small star, and we see its allowed energy levels, in which one of the planets that it creates will go into orbit along. And a larger star will have energy levels that are further apart, that are much larger, and one of its planets, which it ejects, will go into orbit along one of these orbits. So in conclusion, Planet X shows that the quantized orbits followed by celestial objects around other celestial objects has to do with the layer they connect with, which in turn has to do with the fact that matter interacts only with matter at a comparable proton density. In other words, at the same or one level below energy level. Larger objects have larger orbits associated with their energy levels, which are also further apart than the orbits that smaller objects have. And these are the references. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.